So welcome to Develop Anywhere, Even the Cloud. My name's Adam Koblentz. Yeah, I'll go back to those slides. I'm the product marketing manager for JRebel at Zero Turnaround. I used to write software at a couple of investment banks in the US, so I'm very familiar with like large enterprise stacks and the challenges that devs face on a daily basis. Welcome to DevNation, by the way. I know this is like the last day, but hopefully there's a lot of good talks left. I'm looking forward to a few myself this afternoon. Now, as far as the agenda, right? The first thing I want to go over is what is the cloud, right? Because everyone has their own opinion. Developers think one thing, ops thinks a different thing, C-level thinks something else. So let's try to figure out what that means for us as developers. And then we'll talk about writing code locally. Then why you may actually want to write code against cloud environments, and some of the drawbacks and what you can do about it. And then we'll also have a demo as well, where I show that I'm able to make changes to an application and develop pretty naturally with it while it's running in OpenShift, for example. Okay, so there's my smiling mug with some code behind me on a board. So what's this talk about, right? It's about developing the cloud. Like, let's be honest. Like, I'm not going to try to say it's about like various technologies or whatever. I'm not here to talk about OpenShift in particular. I'm here to talk about just why you may want to conceptually write code in some cloud environment. But there is more to it, right? Like, obviously, I'm not just going to talk about like the cloud as if it's some cool nebulous thing with quotes around it and draw pictures of clouds on things. The questions really are, why should you write code in the cloud? What does the cloud even mean in this context for us as developers? It seems like it might be a lot of work if you've ever dealt with any of these things. Like, Docker's cool, but there's a lot of work involved in it. Platform as a service is cool, but there's a lot of work involved. One through with a lot of tools, et cetera, and is this even really a good idea? So let's talk about what is the cloud for us, right? Traditional definitions, there's infrastructure as a service, platform as a service, software as a service, whatever as a service, right? Everyone's saying that they're doing the cloud, when in reality it's servers running in someone else's house, right? So for devs, really it just means I want to write my code. I don't really care where it's running. I just want it to work, and let someone else care about the acronyms. I want a platform that I can run things on and I can interact with conveniently, right? Part of the things is like, I don't want to have to go through having to set up this whole environment. I'm not an ops guy, right? So why do I have to know how to configure MQ and whatever else, right? So maybe you want to take advantage of cloud services. Maybe you're working in a large corporation and you have cloud services, or someone else wrote a service and you have to use it, right? So before the cloud, there was the dev box. The old school, I have a really big desktop machine and it's got all the RAM and processing power that my company is willing to pay for. Then, and it was okay, right? We all had limitations, we all did stuff, and it seemed like it was natural to work with within these limitations. Like, fine, we're gonna have to stub out these things. I can only run these 2 apps at a time. I can't run this other one. I have to, it's okay. I have to install 3 versions of MySQL because of whatever, or whatever you use, right? So there's also restrictions on workstations, right? Like you're bounded by CPU, you're bounded by memory, you're bounded by network. These are all things that you're stuck with, and this is why like the cloud becomes enticing. It's more powerful than what you have, right? But there's also restrictions on the cloud, like network connectivity. There's money, because these things aren't necessarily free, right? They maybe all have free tiers, but they're not all necessarily free. And environment, sometimes you have vendor lock-in for certain types of things. Like if you're using OpenShift, right, that's great because you can use whatever you want for the most part. But if you're using, for example, like Amazon Web Services with Elastic Beanstalk, you're stuck with whatever they support as part of Elastic Beanstalk. And then you have other as-a-service acronyms that come into play with all that kind of stuff, right? And time, because you might spend a lot of time dealing with cloud stuff. Not only that, it also might take you more time to write code against the cloud environment. So I have a MacBook Pro and it's really fast. Devs think, you know what, my machine's faster than my friend's machines. I don't have these problems. I can compile my code so fast. It's awesome. Until we start using these things for real complex development. So just for fun, I did a Google search for Java microservices conference talk, just to see how many references to conference talks there are about Java microservices, right? And the idea is that now if you guys are being told, hey, you should really be running 10 apps at once instead of this one monolithic app, right? And they should all be in their own JVM. And they should all have their own resources, right? How many JVMs can you realistically run on your computer, right? So my MacBook Pro is great. I can do all kinds of stuff on it. But, it's just a lot. It's asking a lot from one computer, right? And the practical reasons that you may want to write code against a cloud environment are, I have a MacBook. I have no way of making that more powerful than it already is, right? Processor, memory, battery, and power, those are all set quantities, right? I can't go to the store and say, if I give you, I can't go to the Apple store and say, hey, I have $30,000, put in a faster processor, right? Even no matter how much money I offer them, they can't do that, right? So now I'm stuck with, what am I running on my computer? What am I going to use my resources for, right? Like I have to then figure out, well, I have to have my IDE, I have to have my browser, I have to have my text editor. Now, because I'm not using the cloud yet, I have to have my database, I have to have my app server or app servers, and et cetera, right? Maybe I have a chat client, maybe I have whatever, right? So now my 8 or 16 gig machine with this really fast processor is now doing these 15 things that I have to have running all the time anyways. And then maybe I have many servers because there's these microservices or whatever, or I have interacting services. And now we get into why why the cloud's important to anyone, right? We get into the offloading of shared resources, right? So the idea is that, yes, in the old days, we all had a windmill, right? People had windmills, they generated power that way. That was horribly inefficient, and that's why we have power grids, right? We figured out a way to pool the energy generation and then deliver it when necessary to people as they ask for it. And this is when you get like a pay-what-you-use model, for example. So I can hook up to this nuclear power grid. I pay some amount of money per kilowatt hour, and that's vastly more efficient than me having a generator in my house, right? So we can kind of take the same theory towards cloud development. Other reasons that we may actually want to use a cloud development platform, right? Unit tests are good, and we also have platform independence, and we also can skip some of the infrastructure stuff. But mocking complicated objects is no fun, and you can run against real services if you actually have a cloud environment. So from my own experience, I had the situation where I was writing message-driven beans, and there were no mocking libraries at the time that actually worked with them. And so my options were I either have a really dumb Pojo that I just kind of say like return 10 or something, and that's it. But I actually would have to spin up a WebSphere and actually run this complicated app just to expose a message-driven bean that I could then run a unit test against, right? So that's crazy, and we shouldn't have to do these things. That's totally unintuitive and unnatural for development. And with a cloud environment, you can worry about the code, not the environment, right? The idea is that your app's running. It's been set up, maybe by you, maybe by somebody else. You don't really care. What you care about is I write code, I see the code work, just as if I had a really simple application running on my laptop, whatever, but now I can get more complex environments. I don't have to worry about the huge setup time it takes to install several databases or configure all the different app servers. Like how many times have you guys started up Wildfire EAP and been like, oh, it failed to start. Why? Oh, the port's already in use because I'm an idiot and I didn't copy this again and change the port again, right? So, or I now have to fight like, oh, I have to do these secure domains and stuff on my local machine. That seems like a huge waste, right? So The idea is that you can not do that anymore. You can just offload that stuff, not worry about it, focus on writing the code. And you can offload resources. Now we're getting back to my computer is really powerful, but now I'm asking it to do more than everyone asked to do before, right? So I can run my app server and my database and my services elsewhere. That means that on my machine, I'm only running browser, IDE, chat client, that's it. I don't have to worry about the app server, the database, et cetera. Now, what's really cool about what's going on in cloud is people are actually starting to cater to developers, right? I mean, how many talks have there been, or how much have you guys seen about develop with OpenShift, or right now there's a competing talk right this minute about Docker for developers, right? Like it's all about developers. We're at DevNation. Cloud's a thing, right? It's no longer just I'm trying to sell your C-levels and why they should move production to my data center, right? Now it's what can we offer you as a developer to make you want to use this stuff too. So because of that, we have choices. One of the really cool things is, no one platform is the best for anyone, right? And I've dealt with all of these. I'm going to show you guys OpenShift today. I think OpenShift's really cool. But I have also worked with the other ones, and they all have their own benefits. They all have their own drawbacks. And it's worth looking into all of them, right? I mean, because the whole point of this is you can figure out what works for you, figure out maybe what your organization can use, can't use, whatever, based on who you're currently partnered with in some way. And then they're all unique. They all offer you something, right? So for example, if all I want is a stupid Linux box in the cloud, I'll use AWS because I'm going to go and do all my ops stuff there anyways, right? I'll go and I'll log in and do stuff. If I want to use Docker, OpenShift is by far the best option right now for Docker for developers in the cloud kind of thing. Now, there are also downsides, right? It can't all be good, because if it were all good, then everyone would be doing it all the time already. So first, internet connectivity. The number one thing people point out when I talk about this stuff is, yeah, but what about when I'm on the plane, right? And what they mean, that's just like a catch-all example for I don't have internet access right now, and I want to be productive, right? So I was sitting outside, and I couldn't get on the Wi-Fi reliably. So we're going to see if this demo works, right? If it doesn't, I'll run it locally, and I'll just pretend. But the point is that it is a real issue. Internet connectivity can be a problem, right? Network latency. Let's say you do have an internet, you do have access, but it's not fast enough, and you are stuck transferring, however many megs your applications are, right? Let's say even with doing Git check-ins or something with OpenShift, right? Depending upon what you're doing, it can still be a pretty extensive upload, right? Tooling. Every one of the providers I showed you on the previous slide have their own tools. So you not only have to learn how to do the stuff that you want to do, right, with that system, you have to also figure out, how do I incorporate this tooling for this vendor into what I want to do, right? And so that means you have to install their tools. Right now on my machine, I have JBoss Dev Studio with OpenShift tools. I have Eclipse with Bluemix tools. I have Google App Engine tools, and something else, right? So my Eclipses are stupid now. They don't even open reliably anymore because of all the stuff I had to install. So tooling's an issue, right? Cost. Most of these providers have some free tier, right? So for example, OpenShift, you get some free access. There's the free gears, at least with version 2. I'm not sure what the pricing platform is for version 3. And with Bluemix, you get some free tier. If you want to use these services, they cost money. If you don't use these services, then nothing costs money, and you can just keep using it. I think Pivotal might be the only one that doesn't do a fully free tier. I think they just have some 2-month trial or something. And vendor lock-in. So some of them, you're looking at having to actually spend time and effort into getting your thing to work in that environment. Then you build stuff that's based around that environment and that tooling set, and then you're stuck with, well, can I move, right? Now that I've put all this effort into getting my thing to run correctly in OpenShift, Let's say, for example, OpenShift version 2. Like I have my thing, it's great in OpenShift version 2. Version 3 came out. What do I need to do to upgrade? Right now I have to worry about my platform, whereas previously you only had to worry about like the app server, right? So like a new version of EAP came out. Yes, I can choose to go to it, I can choose not to go to it, I can choose to migrate in the approved path, whatever. Not only that, but it also takes you a lot of time to actually get your code to run in the cloud and get your code to run to the cloud. So even without introducing any of the time-wasting things involved in the cloud and the tooling and everything else, the average Java dev takes about 1 full work month per year waiting for redeploys and restarts of their app server. So if you sit down, you think about all the times and how many times a day you say, build, compile, and then restart your app server or redeploy, it's about 1 work month a year. And like I said, every vendor has their own tools. You have to, there's all these different tools. They all work slightly differently. How do you come up with some kind of standardized process so that you as a developer aren't hurt when your company decides they want to shift or whatever, right? Because you have this process that works for you. You have a platform that works for you. You don't want to have to change stuff, right? So there's some mitigating techniques that you could use. So for the tooling is different for every platform. Maybe you write some custom tooling. Maybe you have these shims that just kind of arbitrarily call whatever the other tools are, right? That's one option. I've seen people do that. They do it for other things like you can look at this kind of technique is used sometimes for like I have different app servers or different like build tools or something, and they just kind of make their own build engine that just calls other build things, and it's a pain. You don't want to get into it. Local dev is faster. Well, you can also choose to only run large things in the cloud and do everything else locally, which I'm actually going to show you here because I actually have a hybrid app. So you can see how you can kind of choose what you want to do and how you want to do it. But realistically, these are just terrible options, right? Because the idea here is that you want to get as much off your machine as possible, get everything running somewhere else. This way, like let's say you have a code check-in, you decide that you've done something, and you want to get one of your coworkers who is in 3 time zones away to just give it a quick look. What I would have to do right now is do a Skype or a Hangouts or something, share my screen, because it's my URL is localhost something, right? And short of having them have to go through and build it themselves and run it themselves, this is the best way to do it. But if you're using one of these cloud platforms, I could say, oh, just go to app-domain.redhatcloud.com / this app and let me know what you think about it, or we can talk about it that way, right? So it's a way for you to be a lot more collaborative as well. So this is just one of my favorite pictures. Like when you start talking about like making custom tooling, or you start having half the stuff's running in the cloud, half of it's not, whatever. I work for Zero Turnaround, and our whole proposition is that we make tools that make development less stressful and less painful. And what I'm going to show you is that probably the best mitigating technique, so let's say moving to the cloud, everyone agrees, is actually a good idea. We think that you should definitely be running your code there, not on your laptop. And so we have a tool called JRebel, which basically lets you reload code changes into a running JVM. And we actually just 2 weeks ago announced that we have a bunch of cloud partners, Red Hat being one of them, where you can actually have your app running in OpenShift and just hit save in your IDE, and it'll actually push the Delta and do the class reloading on the OpenShift instance. So we work with a whole lot of other stuff too. So if you aren't using OpenShift, that's fine. Basically anything that you could want to use is supported. And basically it's Java classes, resource files, over 100 frameworks. And it basically delivers on the promise of what hot swap was supposed to do, like let you actually change code in the JVM while it's running. We also let you actually maintain state because we don't take the app down. So I have an application that I wrote for this talk, and I have 2 services that are running in OpenShift. So for example, I have a user service and a book service, and they're both basically using JPA and exposing REST endpoints through JAX-RS. And then I have a library front-end app that I'm actually going to run off of my machine. And you'll see that I'm actually able to pretty naturally develop like as if I were using it locally, but even faster. And you'll see that assuming the Wi-Fi actually works, that we're actually able to make these changes and like develop for real as if this were a local thing. So demo. So let's see how this goes. Okay. Okay, let's see how this looks. Okay, is this, yeah, you guys can all read this, right? With my gigantic font now. Cool. So this you probably can't read, and it's slightly off screen, but that's okay. So I have my book service. Actually, I'll try to drag that. Yeah, so I have my book service, I have my library application, and I have my user service app. Now, you may notice that I have the console here showing me that like my transactions are being committed. So this is actually like Jerebo pushing the code changes into OpenShift. So I can just make changes and you'll see it actually work. So here I've got my library app. I'm just actually going to run this one locally. This is showing you that you can actually, that like one of the benefits of using like a cloud platform is you actually can mix and match what you're using across your applications, right? So instead of you having to just run like Wildfly for everything or EAP for everything, it's actually really easy to use these cloud platforms to give you access to whatever, and then also run other things locally if you want to. So this is actually like a Spring Boot app, right? So I'm showing you that you can use many various things all together. So I've got Java EE, I've got exposing REST services, and I've got a Spring Boot app that's consuming REST services and using like time leaf templates, which look terrible because I'm not a graphic designer. So the idea is that we have like this user service here, and that's causing /users, right? Now I can look at the actual code there, and this is actually using this user service app right here. And if you notice though, that's actually running in Red Hat Cloud. So I'm going to pull up my here. Okay, so in OpenShift, all right, the Wi-Fi is working, great. This is that same user service app. So I can click on that, and you can verify like this actually is running. Do this. So this actually is running, right? I've got my Wildfly server. I could have EAP, I could have whatever. And this is using version 2 of OpenShift, right? Because version 3 is not a hosted thing yet. That's the enterprise on-prem only. But if you do install, version 3 on-prem, you'll see the same thing work. If you're using version 2 right now with, with the cartridge-based system, this is what you should expect to see. Now, if I click on that, there's no index for this, right? So I have to go to, like REST users or something. Okay, cool. So that worked, and you make this bigger. Great. So that works. Let's see what else we can do here, right? So 0. So I'm just querying, this REST service. It works the way that you would expect it to. Just call users. Okay, this is all of us. Now I also have my book service. So let me go back. Applications, and I'll go to book service. Okay, same thing. So here I am. I'm using 2 different Wildfly servers. So this would be running multiple on my laptop, and I don't have to. Can also go here now. Okay, so this actually has index.html, and just for fun, I'll do REST books. Okay. Okay, same thing. We have our books, and that works. Now, what I can do here is I can also show you that in my JBoss Dev Studio, I have Jerebo installed, and I also have the URL that I'm hitting in my browser specified in the plugin. Now, one of the things that people might be a little worried about is if you're running your code in the cloud and you're transferring your stuff to the cloud environments, what about the security aspect, right? Like what if someone actually was sniffing and they got your class files over the wire or something? Right? That could be a big deal based on what you guys do. Well, we actually support public key crypto here. And so when you say you want to use this, we actually include your key in a file that we put inside of your deployed app. So it actually knows how to work and does everything the way you would hope it to, and no one can just sniff it. Now, just for fun, what I can do is go to my user service app, for example, and I'm going to change the REST service So let's say that I want to, instead of having all users work this way, find all ordered by ID, I can actually go to my users. Okay. And I can actually add a new, I can change which named query I use, right? So if I go back to the service itself, actually, that's not where I want to go, sorry. We go here, okay. This is actually too big for me to see, but that's fine. So the idea is here, I'll change this. Instead of using final order by ID, I'll do this, and I'll change it to one of the other ones. So find all users, and this is being ordered by name instead. Okay. So if I go back to my repo, I'll just do this. Okay, that should work. See users, final users, great. Go back here. Now, if I click on this, you notice that it actually did commit a transaction right there. Okay, so if I go back to my library controller, or sorry, my app itself, I can now hit refresh. Okay, and you see that it actually reordered it, right? So instead of using the JPA name query that was doing order by ID, now it's just doing an order by name, and that's why we have 015243, because Ashlock comes after Arun, right? So I showed you that this was actually running in the cloud. I'm not actually doing this on my machine. And we can also verify in my browser, for example, if I want to call that again. Go back here, go to the user service. Right, and we see that it's still ordered by name, not by ID. Now, we can also do other stuff too, right? So let's say that we want to do something else, like we want to add a new path or something, right? So right now, my normal get does that. Let's do this. Let's change this, copy that, paste it. Now do another path. Okay. Now this time, I'll do something like just crazy, like DevNation. Hit save. List all DevNation. Okay. And this one's going to be done by order by name. Okay. So now when I hit save, that actually committed the transaction again. And now I can actually go to that /DevNation. Back in my browser, just users /DevNation. And that actually works. So I don't get a 404. It actually is able to find it. And I can prove these are actually different paths, because I can now make this one go back. So I'll change this one back to the ordered by ID. Right, hit save, go here. This one's still going to be by name. And the other one's now going to be back by ID. Oh. Can't be the first person to have done that. Okay. So now this one is actually back to being ordered by ID. So we actually were able to actually add a path, and then we were pretty naturally able to just make a code change. And we're basically treating this app server running, I have no idea where, like a REPL, right? A read eval print loop. So we're actually able to just hit save. The incremental compiler in Eclipse or JBoss Dev Studio kicks in, and we just transfer the delta over to the app server and make the change. So now we get all the benefits of a cloud environment, right? So like I have this app, it's got 3 JVMs running. 2 of them are actually like real Java EE apps with JPA and everything, and the one's like a Spring Boot app, and it's all offloaded, right? I don't have to worry about this stuff being on my laptop. Because I know that even without that stuff running, if I get in like a Hangout video chat, like my computer uses all of its processing power, and it sounds like it's taking off or something. So sometimes my computer doesn't even like render the screen correctly if I have a Hangout and like lots of stuff running. So if I can get as much of it off as I can, the happier I am. Now, like I said though, like I own all of these services, right? So that's fine, and I can write unit tests that I can say like is my library app going to correctly render the stuff, right? or is my library app going to pull in the things correctly? Is it going to have the right kind of form data? And most of it I can use mocking libraries for, or I can use various like just hard-coded things in or whatever. But what if, for example, like you worked in a larger corporation and you have some service that actually is really complicated, right? Like there's some like transaction service that does like some stocks or something, right? And now you're stuck rendering this thing, or you have to then build a really simplified version of this thing in your unit tests or whatever, and that sucks. Like you don't want to do that, right? Like one of the apps I worked on, it had it was using an autocompleter. So like when you started looking for like a stock or something, you typed in the symbol or the name or whatever, and it would take the data from the last day's trading data and run through a whole bunch of probability engines to figure out like what people are actually looking for. So when you type A, it knows even though like A may or AA, right, that may actually be a quote or a symbol, but you probably mean Apple, right, AAPL, because that's the most traded stock or something. So my code had to look for all that. Now, because I didn't have access to this kind of technology, I had to basically write a really stupid trainer thing that pulled from some other service in the company a text file or like a CSV that had all of the symbols and like the trading metrics and everything else from the last day. And then I have to do all that stuff myself, where I have to then pull this in as stocks and everything, and I have to create my own entities and handle all this myself. And most of the code I had to write for this thing was not actually for the thing, but for making the thing testable, right? Or to even feed it in the first place. Now, if I'd had something like this, the guys who wrote that service could have exposed it to me in a way that I could have consumed it and actually been able to do this kind of thing. And especially since it's in the intranet, so they wouldn't really have any concerns about the security of it. At least, well, they would, but not as much. So I can also show you other stuff too. So for example, let's say I did want to change this Spring Boot app, because it's pretty common actually to have a Java EE app that has some Spring stuff in it. So if I go back to my library controller, let's say I want to change something here, like I want to add a new request mapping or something, right? Let's do that. So I'll take my normal root request mapping. Okay, I'll copy it. This is going to be home again. And we're going to have it be /home. And this one is going to return home again. And I'm going to create a new template for it too. So I'll go back to my library app here. And now we can also like add new stuff to our applications. We're not stuck just modifying and making small changes. So I can actually go to my app, add a new template. I'm going to copy this one. Okay, that's fine. I'll call this one home again. And I'll actually change that one too, so we can see that actually is different. Okay, hit save. Refresh. Okay, go home, and then go home again. Now this one gave us something. What did it say? Maybe. What did I do wrong? That's why. Because it should just be /home. There we go. So typing in the right thing actually matters. So the point is that we were able to make a change here. We actually added a new time leaf template, and that kind of stuff also works. Now, let's say that I wanted to add a new class to one of my services, right, running in Red Hat Cloud. So I go to my book service, and I can add like a new like util or something. So let's do that. And this one's going to be DevNation util. Okay, and this is just going to have I don't know, just a method, just like it returns a string or something, right? So okay, so I'll save that, and now in my service or actually in the model or wherever I want to do this, I'll just actually call that. Right? So from here, I'll change it so that get title turns title plus DevNation till, actually, I'll make it static. Makes way more sense. Yep, so do that, go back here. Okay, so now I'm actually modifying the entity as well as I added a new class. Okay, and they're both saved. Okay, and we gotta go back here, we just verify. Oh, the Wi-Fi may have dropped. See what happens. Yep, okay, cool, they both worked. So now I can go back to my service, go to the book service. Okay. Yep, cool. And that worked too. So we were able to actually add a new class. We were able to modify our entity, with that new class, and I didn't have to do anything. I didn't have to interact with the tooling. I didn't have to do anything, right? So the idea is like I use the OpenShift tools to get my stuff running the first time, and then after that, I don't worry about it again. So it's not as integral of a thing for me to actually have to know how the tools work or have to deal with them that often. I'm not constantly having to. So for example, if you're using OpenShift version 2, you'd have to do commit and push, and then that push actually pushes it to the OpenShift repo. That OpenShift repo then triggers the image to get pulled down. It restarts your Wildfly. It does a build and all this stuff, and then it pushes it and runs and starts your Wildfly again. So if you do have a really complicated app with state of any kind, that gets lost. Not only is it lost, but you also have to wait for this thing to actually happen, right? And so I think it pretty effectively showed this actually works, and it's pretty cool. Now, yeah, this is good. So it's getting cut off a little bit. All right, the point is that writing code in the cloud can be awesome, right? You can actually offload whatever you want, as much as you can off of your local machine. Theoretically, you have way better than conference Wi-Fi most of the time. And there's some good reasons to do it. Writing code in the cloud can also be awful, right? Because if you are stuck with the tooling and you are stuck with the downtime associated with the tooling, like OpenShift actually does it pretty quickly. OpenShift actually does pull up a new Wildfly pretty quickly. But let's say, for example, you're dealing with like EC2 or AWS, for example, and you're in charge of doing this yourself, right? You have to package your own WAR or EAR, and then you have to copy it yourself, and then you have to deal with the tooling on the remote end. You have to deal with redeploying your app server. You're talking about having to transfer however much data, and that can really just be annoying, right? So it's dangerous to go alone. Take this, right? Another awesome picture. And if you go to that website, 0t.ee/devnation15, there's actually a 14-day trial for Jerebo. And we also have cloud partner pages now, which talk about some of the all of the benefits and stuff for our various cloud partners, like OpenShift. I think we have some time for questions.